Shall we start, sir?
We can start. I'm available.
Okay. So we are very happy to welcome Dr. SP Syed Ibrahim, Senior Professor in the School of Computer Science and Engineering at VIT University, Chennai. He is a well-known academic leader with more than 18 years of experience in teaching, research, and administration. Dr. Syed is an expert in artificial intelligence, machine learning, and big data analytics, with over 60 research papers in reputed international journals and conferences. His work has a strong international impact. He has built collaborations with top universities like Deakin University in Australia and the University of Queensland, ANU, and UNSW, Australia. He has also enabled student internships with leading companies like PayPal, IBM, and Amazon. As Deputy Director of International Relations at VIT, he has played a key role in MOUs and dual degree programs, greatly strengthening VIT's global presence. I am personally proud to introduce him here today as he is also my PhD supervisor, whose guidance and mentorship have been a big inspiration for me. We warmly welcome Dr. SP Syed Ibrahim, sir.
Thank you, Dr. Wesley, for your warm welcome. I thank all of you to stay at this time and wants to hear from me. I hope I will make use of this short time to give you a lot of good inputs. Hope to so. So the topic given to me was introduction to machine learning, and I feel that yes, it is important, but on the same time, I want to move towards deep learning for network intrusion detection system. In what way? So initially, I will give you a very brief idea about some part of machine learning, as you are already started doing with clustering, classification, all these things. You are already aware of what is machine learning. So I will give you some important information about ML and DL. Then thereafter, a few fundamentals of deep learning. Then we will start to understand about the application where we can apply machine learning and deep learning algorithms on network intrusion detection system, which is current research of mine. And then we will try to understand how we can apply deep learning algorithms over NADS system and how to detect it and current challenges and what may be the probable research dimension you may think of. So when we consider algorithm versus machine learning algorithm, uh, generally that there will be a definition, and they mentioned that is machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And by seeing this term, many of them are confused with that as do we need to program or not? Actually, we have to program, but in a different way. In ordinary existing programming environment, what we will do is we know the input, we know the rules, and those rules will be typed or programmed by using a programmer. He will type a program by based on the known inputs, known rules. Then the computer will use that rules to execute, and it will provide the output, and it will go back, and the program will do the modification and all stuff. But nowadays, that machine learning, deep learning, and even now ChatGPT and other things are actually uh, behave in a different way. We know the input and we have some output, which is all the historical data. And those two things will be given to the computer, and computer will learn about these two things, and it has to develop rules. In other words, it should come out with the program. That program should execute and give some results. Now, this is the current way how we have to understand about the machine learning, deep learning, and Gen AI. All these things are actually working in the same way. We have to provide some known input, and based on the known input, it will try to understand and provide us a rule, and that will become a program. So we don't want to write the program, or we don't want to write a code to do what it should do. Rather than that, the system should be in the position to learn those rules and it should react. And more about ML, here we want to understand, we want to create a model by using some defined and paused parameters. That these parameters are learned by using the known existing historical data. So what is the learning? The computer should be able to understand the data and it should bring out some rules in optimized way. So the optimization is the one of the important thing in developing machine learning algorithms, and we need a past data and past experience that will be given to the system. I hope you are able to understand what is classification, supervised learning, unsupervised learning. In supervised learning, we will have some data set with the class label, and we will supervise whether the output is right or not in terms of training and testing phase. If during the training we can understand all the outputs are coming correctly, that is meaning that it learns it properly. So that is the way how we will have model and learn. Now the question here is, what is the role of computer science in this AI, ML, DL frameworks, and what we can play our role? As a computer scientist, we need to think about the first one is the optimization. What is optimization here is that the system should learn from the data, and there will be a lot of learning and training.
Excuse me, sir. Sir, sorry to disturb you. Some people couldn't see the presentation. Can we reshare it?
Yeah, sure. Are they able to see now?
Miss Priya, is it visible to you now?
Yes, sir.
No, madam. For me also not visible, madam. I think only
Okay.
just normal oral discussion is going on.
No, sir, it's not visible.
Oh, Madam Vaisali ma'am, what about you?
Yeah, it is visible, sir. So you can close the presentation, then open it again and try.
Okay, otherwise I can join again. Maybe there may be
Okay.
some challenge.
Okay.
Are you able to see my screen right now?
No, sir. What?
Oh.
Evening it is clearly that madam shared, na? That I can see, sir. Sir.
Yeah, it is visible.
But where is the problem, sir, madam, in my same thing
No,
I'm doing.
Can you please others, can you please clarify?
So it's visible. Maybe you can log out and come inside, sir. The other person, the participant. Okay, ma'am.
Okay, shall I?
Yes, sir, you can continue.
So yes, sir, you please continue.
So there are
Now it
two
is
things.
visible, madam. I closed it and opened, madam.
Okay, that your problem with your end. Okay, that's fine.
Sorry, sir. Sorry, sir.
No problem. Yeah. So now computer science has two folds. One is we need to understand how to optimize these algorithms, as those machine learning algorithms are computationally, they are it takes a lot of computation, and we want to optimize it so that learning will be better and we will get a better result. The second, once model is learned, we want to show those results, and the inference, the accuracy, all the other parameters, the evaluation we have to evaluate, and that those things needs to be efficient. And out of all these things, we have to consider space and time complexity. So we have to develop learning algorithm in such a way that we want to get a better accurate answer. It's not only accuracy. I want to say that all the evaluation parameter, we need to get it in a proper way in a quick time, right? So in this line, we already learned about unsupervised learning, supervised learning, and reinforcement learning. Some of the these are the types of machine learning algorithms. Now we are jumping into deep learning. So how it is different? Everyone talks about deep learning and machine learning, but how the deep learning is different from machine learning? For machine learning or deep learning, all are it's a subfield of artificial intelligence. The meaning of artificial intelligence here is we want to provide a system some intelligence to that. So when we develop some algorithm, that algorithm will work on and it will give us some kind of results. Is it intelligent enough? Are we able to intelligently learn from it? So that way, how our human brain thinks, the same way the system should learn from the data and it should give us some results. So in deep learning, we will have a biological structure and it will actually will mimic the functioning of the brain and it will learn from the data by using this biological structure. So logically speaking, here it is better than the DL is better than ML. In what way? So sometimes ML works very well for some cases, but sometimes it fails. On some cases, which is actually the human is able to do it very simply, but the machine learning is not able to do it. When it will do it, when it is not able to do it, actually, when there is a unstructured data, then the machine learning will not work properly. And if the data is huge, it will not work properly. Say, for example, if by seeing one or two examples, we will be able to differentiate cat versus dog, but machine learning algorithm will not be able to do. Same way, we will be able to hear some audio clip for one or two times. Then we will be able to differentiate, but the system is not able to do it. So to avoid these things, we are going with DL, deep learning methods, and it will work better and better than machine learning, provided you have to provide him data. Huge amount of data is required for your deep learning algorithm to learn it better. Okay. And another thing is in machine learning, we have to do our the pre-processing. We have to do extensively in terms of pre-processing. What I mean here is that choosing the right features and feature extraction. Those things we'll spend a lot of time. But in deep learning, it will try to take it automatically. Automatically means that it will it will do some activity. Based on that activity, automatically it will try to fetch the good important features. And here I show you the new rule of thumb. So starting from statistical modeling, if the data is very less, it's not that much complex, then we can go with statistical modeling. If data is little high and little more complex than the small one, the statistical model, then we can go with. Now we are going with the deep learning. If the data training size is requirement of training size is very high, and when we go with the deep learning model, definitely you will get a better model performance. Right. So now here we have a small. We will see how we have to develop an DL model. So here I want to show in two different ways. One is structure wise, another one is learning wise. We have to understand the deep learning structure, and then we need to understand what is the meaning of learning and how the learning will happen. Okay. Let us go with the structure. When we go with the structure, we have to understand about input. What is input? What do you mean by this? And what is known as activation function and how it will behave? And what are the different types of layer? And what is the meaning of weight? And how to get the output and how that will be interpreted. So a small example is given here. We have 3 input. So okay, 3 input and some hidden some layers, and we have 2 outputs. How we have to design all these things will be shown in the coming slides. Okay, is there any doubt till now?
No doubt, sir.
No, sir. No, sir.
Okay. Right. So,
No, sir, clear.
Okay. So deep neural network or otherwise deep learning. So here we call this as a deep, as if we increase number of hidden layers, then it will become deep learning. And generally, actually, initially the machine learning starts with this neural network structure only, but they had only input and output layer. In between, they don't have any hidden layer. But now we are able to add more hidden layers because of we have a huge computation environment right now. Because of that, we are able to add more hidden layers. Okay. Is DL new? Is deep learning new? According to you? Can anyone say, is deep learning new?
No, sir.
Actually, this learning paradigm and deep learning and neural network starts from 1948. That evaluation happened, and then 1978 onwards, they are able to come out with a multiple layer perceptron. And again, still 2000, they are not able to perform very well as the data is not available on the time due to the high cost of the storage environment. Another one is computation is also not that much efficient for this. Now we have huge storage with less cost and computation environment. So these two makes DL new, as we are able to process it, and now a lot of new algorithms are coming out. Okay, so now logically we want to create this network, and to go with this, I hope Dr. Wisely has shared all that two documents with you. Is it so?
Yeah, I'll share now, sir.
Okay. Can you share it, ma'am?
Yeah.
Yeah. Now we can go with a small demo and come back to this theory part. I hope you, all of you will know how to use this Colab.
Yeah, both shared, sir.
Okay. So there is a file named Introduction to Deep Learning Keras, but by the month of September 2025. Can you load this file into your Colab? Shall I proceed? Can you please confirm? Can you please confirm? Shall I proceed?
Yes, sir.
Yes, sir.
Okay. So now here I wish to show the deep learning framework using Keras. It's very simple to understand, so that I used this. Generally nowadays we move to PyTorch, but as of now, as a beginner or even if you have some experience, it's better to understand this in a detailed way. Then you can switch over to any of framework, software framework to develop your. So here, so Keras is a very simple framework, and easily we can integrate a number of we can make use, we can develop the deep learning framework, and we can add number of nodes, number of layers easily here. So that is the reason I used this for the demo purpose. And logically, first we want to make some models. We want to create models, and we want to have some layers, and we want to create the network first. After creating the network, we need to understand what would be the input and how that input should process and what will be the output. And then automatically it will take care of the training and it will give you the result. So when we start like this, here we are, we want to have some random seed. And the logically what we want to do here is we want to create or we want to generate some dummy data for 1,000 students. And the same way, we want to create dummy test data for 500 students. And we want to have three columns or three features. We want to have age, number of hours of study, and average previous test score. These three we want to have as a parameter, and we want to have class labelers, whether he will pass or fail. So the same way, we want to create these 1,000 students data set for class label, one to represent pass and zero to represent fail. Okay, so now we will try to execute it and understand. We want to see the data set. So now we have some data set. So this data set consists of three things. Actually, it's for understanding those data. Actually, we make that as a 0 to 1 to represent the data. So three data, and if you see the test data, you have a test value also given. Okay. So now we have created training data and test data.
Sir, you are in mute, sir.
Hello.
Sir, now it's audible, sir.
How much time it's not audible?
Sir, when you are
Last 5
explaining
minutes,
the
you were in
layer,
mute, sir.
sir.
Oh, I think someone muted me. Yeah. Okay, I will go back to my presentation from here, right?
Yes, sir.
Okay, so we have to understand about the structure and learning. The first we have to understand about the structure wise how we have to design our neural network. Then thereafter we need to understand how to make learning possible with this given network structure. So to understand this network structure, we need to understand about what is input, what is the meaning of neurons, and what are the activation function and how to use those activation function, and what is the meaning of layers, and what is the meaning of weight, and what is output and how to get the output. So actually, here I have one sample network. Say for example, here we have about 3 input nodes, and we want to have about 5 hidden one layer 1 and 5 nodes, and in layer 2 we want to have 4 nodes, and output we want to have 2 nodes. So something like that we want to create a network, but rather than two output, I want to have only one output, and let us see how this can be created. Right. So now I hope you are able to load your files. Are you able to load the files? The particular file. Yeah, introduction to deep learning into your Colab. I hope.
Yes, sir, we can see, sir.
Okay. Are you able to load it? If you have time permits, you can load it in your system. As I already shared that file with Dr. Wesley, and she also shared with you. Now, here we want to use that Keras network, Keras as a package. It's a simple framework to develop your deep learning application. So here, what we want to try is here we are saying like we wanted to have a sequential model. Meaning is we will create the input, then the next layer should be something, the next layer should be something, and next layer should be something. That way we want to create the network. So here we are mentioning like it's a sequential. And the dense is how those networks should be connected. So if you see this diagram, say if I take this, consider this particular node, this node is connected by all the previous nodes, all the previous layer nodes. So these three will be connected with the each node. So that way it's a dense one. Okay. So now we want to you want to create some dummy data set to experiment our program. We want to develop a learning algorithm, deep learning algorithm to get a learning and prediction. Okay, what is that? Here we want to create about 1,000 students of some data set for training and 500 student information for testing. And what we want is we want to have about 3 features. One is age, hours of study, and average previous test scores. By using these 3 things, we want to develop a system that should predict whether the particular student will pass or fail. Okay. So for that, what we are trying is here we want to create a data set. Here the training and test data set is created for 1,000 training samples with 500 test samples. Okay. And here we have created the labels, and we have the label of pass or fail. So one means pass and another 0 means fail. So that way we want to create. So you can execute it in your system. If you execute it, you will move forward, and we will be able to see the training data set. This is all about the training data set with 3 features. And the same way, you have a test sample with the 500 transaction with the 3 samples, 3 features. Right. This is important component here. So he already mentioned that what is the meaning of sequential. So here what we want to do, we want to have input dimension as 3. Why input dimension is 3? We created the data set in such a way that we want to feed age, number of hours of study, and one more here, age, hours of study, and average previous lesson score. These 3 we want to pass. So that way we want to create a input dimension of 3. And then the next layer, we want to have 5 nodes in the next layer. And the activation function we want to use is real. So the same way, we want to create another layer with 4 nodes and activation function is real. And finally, we want to get one output, and that output we want to use sigmoid as the activation function. And we will try to understand what is the meaning of compile, what is the loss function, what is optimization, what is optimizer and metrics. These 6 in the coming slide. Can you execute and then see the results now? So here you can see it provides a summary of how that network is created, and you can make the training model.fit training data and the labels you can pass on, and you can make the system to learn. And now it is going on epoch, multiple epoch, and now we can pass the test data to see whether how the prediction is coming up. And here you can see about 48.48 and 0.51. The accuracy is actually not too much. It is it is giving us only 50% accuracy. As the data is random, the learning is okay. But this is the process to understand how the training and testing will happen here. Okay. So some variations. So we have we used some other variation here. And it is also not giving proper result. And here we are changing the data size to understand whether it is working or not. And here we have changed the number of layers and number of nodes in that. So can you tell me what is the meaning of 10? Input dimension 10? So meaning of that input dimension 10 is we will pass a data set with the 10 features, and we will have 64 nodes in the layer number 1. And layer number 2, we will have 32 nodes. Layer number 3, 16 nodes. Layer number 4, 8. And the layer number 5, 4. And then finally, we will get one output, one layer as output. Let us see whether it is working or not. It starts with 50% accuracy. But still, even though we have all these things, it's not able to give us better results. But here we can see how the predictions. Okay. Is there any doubt on developing a simple deep learning application?
No, sir. No, sir.
Okay. So right. So now just now we saw about how to create a deep learning framework, and generally the input is always it will be known as tensors in deep learning framework. So what is tensors? It's nothing else other than our matrix format. So if we have a matrix of our data, then we can call that as a two-dimensional tensor. So column, rows, and columns, that if you feed that, then we can consider that as a table or matrix with a two-dimensional thing. So that we will call that as a two-dimensional tensor. So each and everything we will feed that as a tensor in a tensor to our deep learning framework. And then always we will feed only the numerical data to the deep learning framework. So if you have a categorical data, that should be converted as zeros and ones using one-hot encoding. Okay, what will happen if we have an image, and how we can represent the image as the tensor? So if you have an image, then it will consist of 3 things. One is RGB, so that we can represent as a 3D tensor. And for each and every image, we want to have one dimension. So we will say here each and every image can be represented as 4-dimensional data. So if you have 100 images, then with the 512 cross 512 pixel value, it can be represented as 4-dimensional data with the solution of the strength of 512 cross 512 cross 3 cross 100. So 3 is for RGB value, and each one will have this combination for each for 100 images. So this way we will represent the data into the system. Right. The next one is the input shape. Input shape is all about the how many features you have. That will be known as input shape. Otherwise, here we will consider that as an input dimension. So here we represented as a 10, meaning here is we have about 10 features for our data set. So that we have to feed it into the system. Okay. Then normalize and standardize scaling, all these things are required for deep learning algorithms. We will convert the data into the range of 0 to 1, and we will feed the data into the system. So one important parameter in neural network is all about the neuron. Neuron will act as our human. Each neuron will have a connection, and all these neurons actually mimic our human brain. What it will do is it will do the computation. Meaning is, for example, if you have the input, each input will go to some neurons, and there will be weight associated with that. So what it will do is it will do the computation of W1 multiplied by weight 1, something like that. It will do all the multiplication of weight and feature value, and then it will go to the next level, and finally, if it goes beyond some level, then there will be output. Okay, that we call that as a neuron activation functions. So here it shows one neuron how it will behave. Say for example, we have x1, x2, x3 are feature values. So in our example, in the first example, we saw about 3 features: age, number of hours of study, and previous test score. So x1, x2, x3 will be the input, and with associated with that, we will have weight 1, weight 2, weight 3, and there will be a bias, and that computation will happen something like this: x1 into y1, x1 into weight 1 plus x2 into weight 2 plus x3 into weight 3. So as we have only 3, this will not come, and plus bias, and we will go with activation function. So here we will apply one function. That function will give us the output. Okay. So what is that activation function? This takes the input, and based on that the function of that activation, it will give us the result. Say for example, we may have a sigmoid activation function. So what it will do is, if the value, the computation did the computation, that W multiplied by x1 dot dot dot. Otherwise, we simply we call that as a W transpose X. That will be computed, and if that value is greater than 0, then you will get a positive output. +1 is the output. And if that value is negative value, the weight multiplied by weight x value is negative, and it's less than 0, then you will get a negative output. Okay. And it actually, based on the range, you will get a probability value between 0 to 1. And here, here we will represent the value in between 0 to 1. And when you say if you get about 0.8, the meaning is probability of getting the positive class is 80%. So that way we have to understand. Okay. So many activation functions we have, and some of that based on the activation function, it will give us the result. Then another one is model. So after constructing all these things, this model is all about how we have to design our neural network. So here we want to make it as a sequential, and we want to add input dimension and dense and all those things. And here everything we will mention it in the model. Right. So till now, what we are able to understand is the structure-wise. What is that? What do you mean? What are the different components of deep learning framework? Is there any doubt till now?
No, sir.
Someone raise the hand.
Yes, sir. Am I audible, sir?
Yeah.
Sir, in the last example that we have executed, we have created an array of 3 dimension. Actually, I would like to
it's
know.
not 3-dimension. It's not 3-dimension. We have created 3 features.
3 features. Okay. What is the output in that feature, sir? How is it being fitted?
In our example, I can show that again. So actually here we have created only 3 features.
Okay.
Say
sir.
here age, hours of study and average test hour, that we have created as the 3 features. This one feature, second feature, and this is all about the third feature.
Okay, sir.
Okay. In
Okay,
what I mentioned is the image we will have, if you represent any image, it's unstructured data, and how to represent the image. If you want to represent the image, you will represent it in terms of pixel values, 512 cross 512, something like that. So that will become 2 dimensions, and one color can be represented. That will be the third dimension, and each and every image can be represented these 3. So totally 4 dimension will be there when we deal with the image data, and if you feed the image data directly.
Yes, sir. I understand that. Thing
Yeah.
is, if the model is being fit here, right? In the example, like a 5 layer and 4 layer and last 1 layer as an output.
Yeah.
In the fitting, how the data is being trained, and what is the output, what is the input features and what is the output it's going to get into.
Okay. I will explain that. Okay. So now you have to understand about this. Here I have 3 inputs. Here one, I showed you 3 inputs, right? 0.00 something like that.
Yeah.
Actually, that was a real value that we are converting that value into between 0 to 1.
Yes, sir.
Okay. So now I say here I have one value. Number of age is 16. His age is 16. Assume like this, and he is studying for 2 hours. And his average test score, previous test score, or whatever it is, it's all about 70 marks. Assume like this. So something like that, each and every student will have the value. Agree? Now, what we have to do is, there will be initially we will start with the weight, and this value, the W1 value will be multiplied by X1 value, something like that. All these value will be given as the input to the system, and this computation will happen. And after getting this, you will get a value, that we call that as a value of Z. The Z value will be something out of by multiplying, adding everything, we'll get some value. If this value is, if I apply a sigmoid function here, that 1 by 1 plus e power minus z, that formula, if I apply here the value is 0.7. What I mentioned to you, it's here the value, all the values are coming as 0.7, assume like this. Okay, so after applying this, or 0.8, so after the value of apply all these things, you will 0.8 is the output of this. Then we will see where the 0.8 will fit. So here it comes as this here. What it says is the probability of getting pass mark is, or the probability of pass is 80%.
Yes, sir. Yes, sir. The probability of pass is 80%.
Yeah.
We have to give input as well as output to train the data, right?
Correct.
So
Correct.
The first 2 columns are input and the third column is output. Is that
No.
what?
First three are input. Here we was here training testing, we already splitted here, and this is for training and this is for testing. That is different. Okay. Here we have labels, and now the labels are here we have labels that is a separate component. So here what we are doing is, here we are passing that input, and here the output, we want to mention the output separately. Okay. Output.
Okay.
The
So
layer,
labels
output
are
layer
output?
separately. The labels are output. So now what we are doing it, model that fit the training data and the labels.
Okay, sir. I got it. Thank you, sir.
Okay. Yeah, we have created the model, and now we are fitting the training data, and the labels also pass on. and then we want to predict for the test sample. So actually, the logically what is happening is the model will be built only based on the training data.
Okay.
We will not feed any test data here. The learning will happen only through the training data. The model will be built over that. Then whether the model is working or not, we will use the test data to ensure whether it is working or not.
Okay, sir.
Okay.
But we have 3 type of input there. Why? Okay. Why the input layer is 5? No, input layer is just 3, right? That's the
Input layers. Input is 3.
5 is the hidden layer, right?
5 is the first hidden layer.
Hidden layer. Okay, sir. Okay, sir. I got it, sir. Thank you so much.
Okay, 5 is the hidden layer, and then another 4 layer we want to create. So we can create any number according to your requirement, according to your thing. You can create any number of layers in between.
Sir, okay, sir. Thank you, sir. I think I got it.
Right. So now generally we will pass the data in a normalized way. So that only showed in the our example. Data rather than show the full data, we will normalize and then we'll send it to, as it's so many optimization because of the optimization technique. Right. These things we saw. Okay. Now we have to create the model, and we already pass on the neurons, and then we are able to develop the model here. So till now we are able to understand the structure wise. The next important component is the learning. So always we will pass the training data to make that algorithm learn it, and then it should come out with the model. So when it comes with, when we start with this, we will start with some weight, and based on the weight we will get some output. If output is right, then no problem. We will not update any weight. But if output is wrong, why the output is wrong is because of the weight. So we have to update the weight. So that logically what we call this is a back propagation. Why we call this a back propagation is, if we have this structure, and here each and everything there is a weight involved. So we will get some output. If that output is wrong, why that output is wrong? Because of this weight. And if you change something, then obviously it will affect this weight also, all these weights, and in turn it will affect all these weights. So if you want to update some weight here, you have to update all the other weights. So this we call that as a back propagation. That is, from backward, all the layers, each and every layer's weight should be updated. Okay, so that is the way how we call that as a back propagation. Right. So now what is required is we have to update the weight. But how to update the weight? Is it random? We should not randomly update the weight. So what we have here is we have a concept called optimization. Even back propagation itself is one of the optimization technique. So we have to update the weight, and there will be a concept behind the derivatives and partial derivatives and chain rule, and the calculus will be involved. Meaning here is we want to understand how that particular weight will affect the output. How the weight is affected a particular output, that we have to understand, and we have to update the weight. Okay, so so many other optimization techniques are available at a grade and something like that, and then we have to understand about the metrics. So this metrics is help us to understand whether that particular algorithm is working properly or not on the training data and test data, and how it is working and how it behaving on the test data. And if we are satisfied with this metrics, then we can take that into the real time. Okay, so for that we have binary accuracy. If your data set is having only 2, we can go with binary, or categorical accuracy, sparse categorical accuracy. So different types of accuracies are available. We can take it up. And finally, we have to use that compile. Compile command is used to make the model, and you can, if you assume that all these things are good, then we can make the model, and we can compile and then execute it. Okay, so this is all about the compile what I talked to you. So we know that there are now, according to this case, there will be 10 input nodes, and hidden layer 32, and another 16 layers, and finally we have only one output thing. So we can pass the data, 10 different input, we can send it to here, this model, and we can combine. So here we are using IRM optimizer, And as we consider there's a binary data, we can use binary cross entropy, and we want to ensure the accuracy is the evaluation parameter. So we can get accuracy for each and every epoch. It will give us accuracy, and end of the time, if that accuracy is acceptable, then we can take that to the real time. Okay. So that for that we may have a validation data set also, which is out of the 60, we can have a 100% data, then we can take that as a 60, 20, 20, 60 percentage for training, 20 for validation, and 20 for testing. So generally we will use that 60% for training, make the training, and then we will use the testing by using that 20%. If everything goes very well, then we will test it with the 20% of validation data set as mimicking a real-time case. If everything goes very well, then we can take to the real time data set. Okay. Can you see this and then tell me what we are trying here? Any one of you?
Actually, 6,000 test training data, 2,000 validation data, and testing data again 2,000 is being randomly created.
Yes, very good. And we want to use the data to test it. And can anyone say about what it's a complete? Now we are able to create a deep learning framework. It's one network we have created. Can anyone say what we did here? Can you give it a try? How many input nodes? How many input features?
Input features are 10.
Yes.
And we have next hidden layer of 64.
Yes.
And followed by 32 nodes hidden layer, again another one hidden layer, and followed by a 16 node hidden layer, and another 8 node hidden layer, and 4 another hidden layer, and finally the output layer 1.
Yes. Here we are using optimizer as ADEM, and binary cross entropy as the loss function, and metrics accuracy as the metrics. Now here we are fitting the model by using training data training data of X training and Y training. It's X train talks about features, and Y train talks about the class label, and batch size, epochs, number of epochs, 3 epochs we will run. I hope you are now able to understand how to create a network. Is there any doubt till now? Okay. If you don't have, yeah, please, anyone? Is there any doubt? Okay, let me go with the next topic, deep learning for network intrusion detection system. So now this network intrusion detection system plays an important role in cybersecurity field. So now logically what we want to understand is what is network intrusion detection system and how this AI techniques can be applied. Meaning internally how this deep learning can be applied on this data set, so that it's a combination of cybersecurity and it's an intelligent cybersecurity system. So what we want to understand is we want to understand how these deep intelligent algorithms can be applied over NADS data or network intrusion detection system data. Right. For that, we need to understand about that cyber security field. It's a cyber attacks are every day there is some attacks are happening, and nowadays they are using this AI framework to make an intelligent detection method. So that is all about what we also want to try. And now we have, if you talk about intrusions, there are two intrusions. If you take a the behavior of the system, there are two things. One is normal traffic, another one is malicious traffic. So the objective is to identify those malicious traffic in the exactly it's a malicious. So that is a key, and it's very important task to do it. To do this, we have a system called intrusion detection system. What it will do is it will monitor the network, and it will try to identify if there is any kind of virus or suspicious activity, that those things will have to be identified. So when we take this, we have two types. One is HIDS. It's otherwise known as host-based intrusion detection system. That is nothing else other than our antivirus. So each and every host, we will install the antivirus software, and that software will try to identify, detect if there is any malicious activity comes in. Otherwise, in industries, they have a network intrusion detection system where they will implement this network intrusion detection before when that any input comes in, the network comes in. So before that firewall, they will have a NIDS system, and this NIDS system will be able to manage and understand the malicious activity, and it will report to the administrator, so that they can be able to block those kind of activity, and that will leads to or that should not lead to substantial loss. Okay. Now, what is the challenge? The challenge is actually it's a voluminous of data is very high in NIDS, as we have to process about 148 crore of packets per second, and we have we could get time of about only just 6.72 nanosecond to detect it. So see the time; it's very very less time we have to detect it. So we have to develop some kind of an AI system. It's an intelligent detection system to detect it in a proper way. So we want to have a great accuracy, and nowadays we have many protocols, and each and every protocol behaves in a different way, and then all these things leads to so many challenges. And another important challenge is low frequency attacks. When we see that network detection intrusions, the normal data will be more in number, but attacks will be very less in number. But however, your algorithm should be able to detect those attacks in a very fruitful manner and short time. Okay. So these are some of the real-time challenges. High false alarm rate, class imbalance is a very big challenge. So now we want to understand how to use this our deep learning framework to detect these anomalies. Okay. And it is definitely machine learning will not helpful, as it's a huge volume of data is exists. And here we have now numerous number of learning algorithms, deep learning algorithms, something like CNN, DBN, DNN, RNN. We can use it, or we can use autoencoder and GAN. And in this, for this, the session, I want to use autoencoder as the one deep learning framework to detect the intrusions. And currently, I am working on rare attack class prediction methods, continual learning, federated learning, few-shot learning, zero-shot learning paradigms for identifying these intrusions. And my scholars are now available there in Australia to do dual doctoral PhD. And in this forum, if any of your friends or your students are looking for some supervisor, you can refer my name, and they can have an option of getting 2 degrees, one from India and another one from Australia, or even Australia, they can get another degree. We call that the dual degree. That is an option, right? So now I will go back to that collab to we can see how to use this deep learning framework to detect intrusions. So for that, I have another collab. I provided a collab file, IPython notebook. You can load that. Okay. So NSL KDD is the one benchmark data set, and we want to use that data set to understand how it behaves and how the learning algorithm is actually applied to understand how it works. So here we have to understand about NumPy, Pandas, Matplotlib, Keras, and all these tools to for this experiment. Okay. So now here what we are doing is we are just importing those required files. And now we have to load our KDD dataset, NSL KDD dataset. It has two different components, training and testing. And we want to load those files into our Colab. Okay, that code is given here, training testing URL. You can download it. And now you can see the training sample, the top, 5 transactions of training sample, how it looks like. And you can see about 41 features and 41st feature is the class label or something like that. And we have this the data set. Okay. And here the testing data set also we can view it. Now the problem is it has only the number as the feature value. Okay, number as the feature value, which is actually not good to work out. So we want to feed ourselves the name. So here we want to pass the name by ourselves. As we know the domain, we are passing the name. Now you can see the training sample versus test sample. So training test is training data set consists of about 1,25,000 transactions, and the test data set consists of about 22,000 transactions. Right. Now we want to see the class label and we want to understand how it behaves. Now, when you see the training data set, it has about 23 outcomes. So 23 class labels are there in the training data set, something like normal, Neptune, and so on, so on, so. But when we take a test data set, it consists of 38 class labels. In this case, is it possible for us to apply a learning algorithm? Training dataset consists of only 23, but test dataset consists of more than that of class label. And whether it is how many are unique, that also we don't know. So it is very difficult for us to apply a learning algorithm. So what we have to do is we have to do some kind of pre-processing and ensure that both training and testing dataset consist of same number of class labels. So for that, what we are trying is we want to convert those all the possible class label into groups. So we have here we can understand that there are 37 class labels and another one is 38. One is the normal class label. So yes, 37 attacks and attack types and one normal class. So all these things are we want to group into these any of those 4. Okay. So now what we will have is we will have about these 4 and plus 1, 5 classes hereafter. So that only we are trying here. And by seeing this now, what is happening is, yes, now the training data set consists of 5 possible outcomes, and the test data set also consists of the same 5 possible outcomes, normal, DOS, R12, and same way here also we can see the same number of class labels available. So now it is good to start with our analytics. So now we want to prepare the features by having a normalization. And then now we are again we want to look those feature values and understand how it behaves. Okay, now we converted. Okay, so now we are we have to convert. We have to make the data into 2 parts: training, testing, and the X component, Y component separately. We are doing it here. And after doing it, we can understand that as the data is now converted as about 1 lakh transaction, and those that 42 features is now expanded to 122 features as we included some one-hot encoding. The same way, your test sample is also consist of 22,000 transactions with 122 features. Now, feature set is we fixed the feature set as well as the class labels, and now there is no problem. We can go forward. Okay. So now what we want to do is we want to create one model called autoencoder. In autoencoder, what will happen is we will have input and then some hidden layer and same number of hidden layer, and then output is same as input. So when we train this model, in the hidden layers will try to learn and it will try to compress it. So based on that, what we are trying here is we want to have 8 nodes. Okay, the input is too many, but we want to restrict to 8 nodes. So after training this, these 8 nodes are more than enough to have the information about more than 122 features. So now 122 feature is converted as or compressed as having 8 nodes, and those 8 nodes will have a information about those 122 features. Okay, so now we are executing it. It's learning now, and now we want to use that particular model to predict the autoencoder model to predict the samples or test cases. It's done. Now we want to see the evaluation parameter. Now it shows accuracy of about 89%, recall, precision, and all those things. And again, we are going with the normal and each and every class label separately. So it gives us some kind of accuracy, and we want to plot confusion matrix also here to understand how it behaves. Yeah, it's okay. At least it gives us some kind of results, and we want to project filing. Okay, the same thing we can try with your KNN algorithm decision tree also. So here I gave the code for the decision tree algorithm and how much it is giving. So yeah, it gives us about 7.76%, 76% of accuracy for the decision tree, and for KNN. For k equal to 5, this can be tuned how much is there. Yeah. It's working on. Okay. So is there any doubt till now? Am I too fast? Did you understand some of the concepts? Okay. Okay. We have another 8 minutes. 8 minutes. Now I will show you the current trends in the deep learning and display. In another 2-3 minutes, I will try to complete it. So now, few shot learning actually plays an important role, and a few shot learning meaning here is actually when you take the IDS data or any other data nowadays, you can even the medical data, all this data actually have a class imbalance. Meaning is a particular class label will be very high in number, and the remaining classes will be very low in number, and even it's a minority. So on the time, these deep learning and machine learning algorithms are actually not giving us the better results, as most of them are working on a probability basis. So majorly occurred transaction will be taken into consideration. In recent years, I am working on few shot learning methods. How that few shot and zero shot come into play here is we will not we will have to consider the minimal occurred transaction, and by using those minimal occurred transaction, we have to build the model. Okay, so here generally it's a logic is something like this. It will it mimic the human brain very effectively. Say for example, you may meet me in 1 or 2 times. Say for example, the last 1 year you met me about 2 times. Those are the only 2 times you met me, and the next year hope you can recognize me and who am I. So what it means here is by seeing few times, very few times, you will be in the position to recognize me, right? The same logic we want to incorporate into our the methodologies that the current deep learning and machine learning methodologies, which is actually we call that as a few shot learning. And here what we will do is we will have a support set. What the support set is, which is a small collection of labeled data, and it's a reference point. When any new data comes in or when we do the training, we will have this as a reference. Say, rather than seeing full length of all the examples of my photo, it will have only 2 or 3 samples of mine. And by seeing that, the system is able to detect whether it is Syed or someone else. Okay, so that is the logic behind the few shot learning. And in those days, they did a data augmentation. They will do the class balancing methods. That is not working nowadays. And they did a transfer learning. They learned for something and then they transfer it. And nowadays, actually, we are using meta learning. Okay, meta learning and multimodal learning and semantic things. So this is the current trend in nowadays in the industry on developing few shot learning methods for the deep learning applications. Okay, so that's my research area. I have recently published many papers, and you could see. I can share that slide, and you can see the references. And if you are highly interested to join with me to do some research, yes, I always welcome you to do that. So thank you very much. If you have any queries, you can ask me right now. If you need any clarification, you can ask me.
Oh, dear participants, does anybody have any doubt here? Yeah. Okay, sir. Yeah. On behalf of the FDP team, I would really like to thank you for having spent such a long time and having given a very clear and engaging learning in today's session, sir. Actually, you have begun with basics of machine learning and you have really connected us to the foundations of deep learning concepts. And also the introduction to deep learning and the Keras, which was explained very clearly and in a simple way, was very easy for all of us to follow. So we would really appreciate also the Python code that you have executed online, and the way you made the sessions practical and interactive was really impressive. And I'm sure all the participants would have understood all the topics very clearly. So this hands-on approach has been, it's really good. So that I would like to highlight that. And the mathematical models that you have also explained, which stands behind the deep learning concepts in a very structured manner, has also given us a very good clarity and very good understanding on the algorithms behind, and the reasoning behind the algorithms. So we are really grateful, sir, for having spent your evening and spend the time on giving us a very interactive and learning session. And I'm sure that all of them would not disagree with me. And I'm sure that they would all take forward these learnings into their own teachings, research, and projects. So once again, we thank you for accepting our request and having spent your valuable time with us. And we also look forward to have you with our future sessions, such sessions in the future, sir. Thank you. Thanks a lot, sir. Thank you.
Thank you. Thank you for your kind words. And tomorrow also I will be there.
Yes, sir. We'll meet again,
Okay.
sir. Yeah. Thank you, sir. Thank you.
Thank you very much. Thank you all. Sir. If you have any query, you can make note of that and give maybe in the next session also I can give you the clarity on that. Share it with
yes, sir. We
Thanks.
have a group, and if students are posting the doubts in that group, we'll definitely forward it.
Sure. Sure.
Yes.
Thank you.
Yeah.
Thank
Thank
you.
you, sir.